Hello everybody, this is Kim, and in this class I would like to solve you a nonlinear knapsack problem using by means of the dynamic programming method, right? The nonlinear knapsack, it is basically the same case as the linear knapsack, but we got nonlinearities in the objective function and nonlinearities onto the constraints, as you will see. The idea is putting the maximum number of items into the knapsack, but we are bounded by this number, in this case 5, that will be our right hand side term. Also an integrality condition, the number of items for all of the variables has to lie between 0 and 2. And as the goods are not being divisible, we are working with integer numbers, so it's a special kind of integer programming problems. So we want to transfer the maximum number of items, because I guess we want to transport them, to move them, but we got a cost function. So we want to move the maximum number of items, but also minimizing the cost function, right? That is we have a cost function for every item. The first thing we have to do to solve this problem by dynamic programming is first realize that the problem is in fact separable. To do that, what we are going to do is isolate each variable, putting the variables together in this way. So minimizing f of minus 2 square root of x1 minus 2x2 minus x3 squared minus 1/2 of x4 cube, and then 3x1 minus x1 squared, x2, x3 cube plus x4 less or equal than 5. Now in this way, it's the same problem. In this way, you will notice that we can, if we look at it in columns, we can name each column as J1, J2, J3, and J4. So we can look at them and we can appreciate that they are really separable if you look to them as a column problem, right? So this problem is separable, and as it is separable, it can be solved by dynamic programming. In dynamic programming, as well as the decision variables, x1 to x4, we have to define a new variable that it is called a state variable. Name it s, for example. In this case, it's just one variable because we have just one constraint. If there were more constraints, what we will have is a vector of s, right? But at this moment, I've chosen a simple problem. We only got one constraint, so we only got one state variable. But this state variable has 4 stages. S1 for j being 1, S2 for j being 3, S3, and S4. Okay? And now by hypothesis, I'm going to assume that the first value of S1 is going to be 0. In other problems, when there are technological constraints, this value could be different. But it's not in our case. We can hypothesize that the value is 0. And as we don't know really what is the value of these state variables, but we know that each of them is going to have a lower and an upper limit. So S1 will lie between a lower and an upper limit that, as by hypothesis, I've assumed that S1 is 0, it's going to be the same value. But the thing will be different from S2. So S2 really will move between S2 lower and S2 upper. The same for S3. S3 will be moving between a lower value and an upper value. and S4 the same, will be moving between S4 lower and S4 upper, right? So the thing we are going to do is just for evaluating the state variables, we are going to work now only with the constraint. So let me put the constraint over here in a vector way, and as all of the variables are moving between 0 and 2, for the moment I can forget about the subscript, so I can put here that from j being 1, this will be 3x minus x squared, comma, for j being 2, this would be x simply, comma, for j being 3, this would be x cubed, and for j being 4, again x. So this is going to be our vector. And also let me say, let's evaluate the vector, because as I've said, the variables are moving between 0 and 2. So if I substitute here 0, what we get is 0, 0, 0, 0. When I substitute here the value of 1, what we get is 2, 1, 1, 1. And when I substitute here the value of 2, what we get is 2, 2, 8, because it's cube, and 2, comma, 2. So now we have substituted the value. Let me clear here. Let me clear here. And now what we have to work is, we need to evaluating what is the value of S2, and to do that we need to evaluate the lower limit of S2 and the upper limit of S2, right? So let me clear here. Let me clear everything because I need space. Okay. The lower limit of S2 is going to be the lower limit of S1, that was 0 by hypothesis. Let me start here. The lower limit of S1 plus the minimum of G for J being 1, evaluated at X being 0, 1, 2. This is the lower limit of S2, and S2, the upper limit of S2 is going to be the minimum of two quantities. The upper limit of S1 plus the maximum of G for the first stage, J being 1, of X evaluated at 0, 1, 2, comma, the right hand side less the minimum of the constraint in the stage 2, X being 0, 1, 2, less minus the minimum of the constraint for J being 3 of X evaluated at 0, 1, 2, less the minimum of G for J being 4 of X evaluated at 0, 1, 2. Right? This is the upper limit. So in the upper limit we have to choose between two quantities. I'm putting brackets here, brackets and brackets. Okay, we have here which is the value of every of the G's. So this is the same as I've said, as S1 is equals 0, and the same for its lower value. So S1 lower would be 0 plus the minimum of 3x minus x squared evaluated at 0, 1, 2, less or equal than S2 less or equal than the minimum of the upper value by hypothesis is 0 plus the maximum of 3x minus x squared, comma, the right hand side 5 minus the minimum of x evaluated at 0, 1, 2 minus the minimum of, for j being 3, x cubed evaluated at 0, 1, 2 minus the minimum of x4 for the stage 4, that is x evaluated at 0, 1, 2. Okay, so to do that, let's to look at these values. Remember, for j being 1, j being 2, j being 3, and j being 4. 0. The minimum of 3x minus x squared for the value of 0, 1, 2. Remember, the minimum is 0. Is 0, right? So 0 plus 0 less or equal than S2 less or equal than the minimum of 0 plus the maximum value for j being 1 evaluated at 0, 1, 2. The maximum, there is a match, is 2, you will see. There is a match over here. So the maximum is 2, comma, 5 minus the minimum at x evaluated at x in 0, 1, 2, that is looking at this column. The minimum is 0, is this value. So less 0 minus the minimum of x cubed, the third stage, evaluated at 0, 1, 2. The minimum again is this value, 0. So less 0, and the minimum of the stage 4, the minimum between 0, 1, 2 is again 0. So less 0. And what we will see is that 5 minus 0 is 5, 2 plus 0 is 2, the minimum is 2. So we know that S1 by hypothesis was 0, and S2 is moving between 0 and 2. Now we have to do the same for S3. So let's do it for S3. Okay, for S3. So the lower limit of S3 is moving between, it's going to be S2 in its lower value plus the minimum of G for j being 2 of x evaluated at 0, 1, 2 less or equal than S3 less or equal than the minimum of two quantities, the upper limit of S2 plus the maximum value of G2 of x evaluated at 0, 1, 2, comma, the minimum of the right hand side less G for j being 3 of x evaluated at 0, 1, 2 minus G for j being 4 of x evaluated at 0, 1, 2. And we are done. So again, substituting S2, the lower limit was 0, 0 plus the minimum of G2 is x evaluated at 0, 1, 2 less or equal than S3 less or equal than the minimum of S2 in in its upper limit is 2 plus the maximum of x j being 2 evaluated at 0, 1, 2, comma, the right hand side 5 minus g being the minimum of x cube evaluated at 0, 1, 2 minus the minimum of x, the fourth stage is x evaluated at 0, 1, 2, and we are done. So 0 plus the minimum, now forget about this column because we have wasted this column for calculating S2. The minimum of x2 of the stage 2 between the values of x being 0, 1, 2, the minimum again is this 0. Let's call it different. Let's call it, for example, with a circle. So this value is 0, less or equal than S3, less or equal than the minimum of two quantities. 2 plus its maximum is 2. Its maximum is 2, so 2 plus 2, comma, 5 minus, now looking at the third column, the third stage, the minimum between 0, 1 and 2 is 0 again, and the minimum in the fourth stage for the values of x being 0, 1, 2 is 0 again. So we are done. So 0 plus 0 is 0, less or equal than S3, less or equal than the minimum between 4, 5. The minimum is 4. So S3, its lower limit is 0 and its upper limit is 4. And now we have to do the same with S4, the last stage. Let's clear here. And let's work with S4, the state variable in the fourth stage. So S4, its lower limit is going to be S3 lower plus the minimum of J3 less or equal than S4 less or equal than the minimum of two quantities, the upper limit of S3 plus the maximum value of G for J being 3 of x evaluated at 0, 1, 2, x evaluated at 0, 1, 2, comma, the right hand side 5 minus the minimum of G in the fourth stage evaluated at 0, 1, 2. Okay? So S3, its lower limit was 0, 0 plus the minimum of x cubed evaluated in 0, 1, 2 less or equal than S4 less or equal than the minimum of the upper limit of S3, that was 4, plus the maximum value. Okay, now we are looking to this column, right? The maximum value, 4 plus x cube evaluated in 0, 1, 2, comma, 5 minus the minimum of the last stage, x evaluated at 0, 1, 2. Okay, the minimum of the third stage between the 3 points is 0. So 0 plus 0 less or equal than S4 less or equal than the minimum of 4 plus the maximum value of x3 is 8. So 8 comma 5 minus the minimum value of the last stage, the minimum value is 0. So we are done. 0 plus 0 is 0, less or equal than S4, less or equal than the minimum between 12 and 5. So the minimum is 5. So the last stage, S4, will lie between 0 and 5, right? Okay, and now we start in the last column, in the last stage, for J star being 4. So we will look in only this column, and then we will get to J being 3, J being 2, and J being 1. Starting in this column, as I've said, what we are going to do is substituting over here the last stage. We are in the last stage. So S4 is taking values from 0 to 5. So I will be substituting over here all of these values. S4 being 0, S4 being 1, S4 being 2, S4 being 3, S4 being 4, and S4 being 5, right? And also X is taking all of these. It's possible. The range in which varies X, if you remember, was X being 0, X being 1, and X being 2. So with these two components substituted over the last column, I will get the minimum of the function, but with one constraint, that is that S plus X has to be less or equal than 5. That is to say, S has to be all the time feasible, right? We need this value keeping feasible, because if not, we will be violating the right hand side. Just substituting the values of S4 being 0 here and X being 0, 1, and 2, we get three results. And of these 3 results, well, I'm summarizing a little bit just to not fill the blackboard with numbers. If you substitute over here these 3 values and S4 being 0, as I've said, we get that for X4 being 2, the minimum of the function of this piece of function is minus 8. The half of minus 8 is minus 4. And now again over this column I substitute S4 being 1 over its 3 possible values of X, 0, 1, 2 over here, right? Discarding the infeasibilities and taking the maximum value, taking the minimum value of the function for the value of X. This happens at this time for X4 being 2, and again F star, the minimum is minus 8 over 2, that is to say minus 4. Substitute again over here S4 being 2 and evaluating the 3 possibilities for X, 0, 1, and 2. And we get again that X4 is 2 and the minimum F4 function is giving us minus 4. The same for S4 being 3, evaluated at 0, 1, 2 for the values of X. This is giving us X4 with a value of 2 and F star, the minimum, of a minus 4 again. Now over here we will be getting possibly infeasibilities because this value is high. 4 plus any value we can be for the value of 2 plus 4 is 6, is just infeasible. So over here we are just discarding possibilities, right? So we evaluate 0, 1, and 2, and what we get is that the minimum goes to, this time, x4 being 1 and f star minus 1/2. 1 to the cube is 1 minus 1/2. And for the last, as S4, if S4 is 5, the only possibility is just x being 0. The rest are infeasible. So the solution of this would be x4 being 0 and f star would be 0 also. The minimum would be 0. Just keep the results in mind, right? Because later, when we have finished using the backtracking formula of Bellman, we will be just getting the solution for the variables, right? For the decision variables. Now let me clear a little bit the table. Okay. So we have complete the stage 4, right? This is complete. This is done. Now I have to move to the third stage. So now I will be looking at this column to the third stage, but I will need to plug in the S3 variable, the stage 3 variable. So we are looking at this result, right? Forget about this minimum right now. And now what we are trying to do is this. We are trying to minimize the value, let me put it in red, the value of f3 minus x squared plus f4, let me put it in black, s4 of s3 plus g for j being 3. We are in this column. J, now j star is this. J star is 3, right? From j star being 3 of x, of course x evaluated at 0, 1, 2. Okay? So inside the bracket, in fact, what we got, this sum is giving us, this sum is in fact S4, right? This sum is in fact S4. So what I'm going to do here, let me see if I have space, because this is going to be a little bit long. I will need to minimize, let's put it, I will need to minimize 4. And also S3 is moving between 0 and 4, so I have to consider S3 being 0 for the values of x, x being 0, x being 1, and x being 2, and minimize this, as I've said, of the values of x over this bracket, over this bracket in red. So the value of, if x is 0 and s3 is 0, the value of f3 is 0 also, right? If this 0 of here is 0, and continuing in blue, plus f4 of s4 being 0, and now we'll be going to the value of s4 being 0 that I've just solved earlier, right? Okay. For x being 1, the value of s3 is minus 1 plus f4 at the bracket of s4 being 1. And for x2, the value is minus 4 plus f4, the value of S4 being 8. Okay, this is giving us 0 minus 4, this is giving us minus 1 minus 4, and this is giving us minus 4 and 0, because it does not exist. So between these three, the minimum is this one, is minus 5. So the minimum is for the variable x3 being 1 and f star 3 equals minus 5. Okay, minus 1 and minus 4. Need to do the same with S3 being 1 this time. Again evaluated at x being 0, x being 1, and x being 2. So bracket, 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 0 plus f4 of S4 being 1, minus 1 plus f4 of S4 being 2, and minus 4 plus f4 bracket of S4 being 9. So this is giving us three values again. 0 plus minus 4, minus 1 minus 4, and minus 4, and there is no value, because there was no value for S4 being 9. Do you remember? The upper value of S4 was 5, and the same here. This is why I put a null here, null and null, because it does not exist, this value. The minimum of these three quantities lies again in the middle, minus 4, minus 5. So x3 being 1 and f star minimum over f3 is minus 5. Okay, I'm gonna clean, because I guess that you will be looking better this part of the blackboard. Let me clear these numbers, but okay, not everything. Let me maintain S3 0 1 0 1, so we need to evaluate 2 and 3, right? 2 and 3. Okay, and start again. So for S3 being 2, substituting the value of x0 give us in the function f3 0 plus f4 of S4 being 2, a value of minus 1 plus f4 of S4 being 3 this time, and minus 4 plus a value of f4 evaluated at S4 being 10. Okay, and we have done. This is giving us 0 minus 4, the first. The second is giving us minus 1 minus 4, minus 1 minus 4, and the third is giving us minus 4, and it does not exist for a value of S4 being 10, because it ended in 5 again. So again in the middle lies the minimum, and we'll be getting the minimum for x3 being 1, for the variable s3 being 2, right? x3 being 1, and f star at the third stage being minus 5. And now we are going to s3 being 3. Okay, s3 being 3, what we got is the function f3, this value, 0 plus f4 of f4 plus s4 being 3, minus 1 plus f4 of a value of S4 being 4 and minus 4 plus F4 for a value of S4. Remember that S4 is the sum, is summing the value of S3 plus G3 evaluated at 0, at 1 and 2. So it's the sum. But when I put S3 being, what I've done just the sum of here, right? Okay, 4 and the last 11. Okay, and so this is giving us these values: 0, minus 4, minus 1, minus 1/2, and minus 4, and null, because S4 11 it does not exist for us, because it finishes, S4 finishes, remember, in 5, right? So the minimum lies for this, the first, x3 this time being 0 and f star 3 being minus 4, right? And now the last value for S3 is this one. Let me clear here again everything. For S3, this is the last value. For S3 being 4, substituting here 4. For S3 being 4, and now evaluating 3 times x being 0, x being 1, and x being 2, we got a value of 0, minus 1, minus 4, because this is repeating all the time, plus f4 of S4 being 4, f4 of S4 being 5, this is the last, and this will be null, of course, f4 of S4 being 12. So this is giving us these numbers: 0 plus 1/2, minus 1 plus 0, and minus 4, null. So the vector lies in the middle now. Again, the optimal solution of this will be x3 being 1, and f star 3 being minus 1. Okay, so we have also completed this stage, the third stage. Now we have to move to the next column. To the next column will be summing here S2 plus this value, and our J star is going to be 2. Is here, J star is going to be 2. So we are looking at this column right now. Okay, so we will be modifying this in the sense that we want to minimize F2 plus F3 of S2 and G2, right? S2 plus G star being 2, and this will be S3. This sum would be S3, right? So we will need to, looking at the value of S3, substituting onto F3. F3 is minus 2x, and taking also all the time the minimum of this function, right? So, okay. So but we are lucky because now S only moves between 0 and 2, so we only have to compute over here these operations. Over here we substitute S2 being 0, S2 being 1, and S2 being 2, right? For the values of x being 0, x being 1, and x being 2. X being 0, x being 0, x being 1, and x being 2. X being 0, x being 1, and x being 2. Okay, and we try to find the minimum, and the minimum. So now substituting onto this column, remember, right? Okay, so the minimum of F2, now I'm following this formula, right? The minimum of F2, that is 0, 0, 0 is 0, plus F3 of S3 being 0. Then the minimum of minus 2 plus F3 of S3 being 1. And the last, the minimum of minus 4 plus F3 of S3 being 2 equals, this is 0, minus 5, minus 2, minus 5, and minus 4, minus 5. So the minimum is minus 9 for x2 being 1, f star minus 9, right? Okay, this is done. And now substituting s2 being 1 and also the value of 0, 1 and 2. So minimizing f2, that is to say 0, minus 2 and minus 4, this value is repeating in all the possibilities, 0, minus 2 and minus 4, plus f3 of s3 being 1, plus f3 of s3 being 2, plus, no, the last is here, plus f3 of s3 being 3. There are these three values, right? Let's to see. So these three values are giving us the minimum is, okay, this is, let me sum 0, minus 5, minus 2, minus 5, and minus 4 again, minus 4, minus 4 this time. So the value, the optimal value is for x2 being 2, the last, and f star being minus 8. This value. Oof. Okay. As you will see, these are methods to be solved in a computer because they are a little bit tricky. And now the last, s2 being 2, and substituting here 0, 0, 1 and 2. So we are taking the same values of f2. What we'll be changing is f3, and f3 of s3, the state variable s3 being 2, 3, and 4. Okay, so this is giving us 0, minus 5, minus 2, minus 4, and minus 4, minus 1. So the minimum lies in the middle. For x2 being 1, f star minus 2, minus 4, minus 6, right? Okay, this stage is also done, and now we are to tackle the first stage. So now we will be moving to this column. Okay, this is a square here, right? And now we add over this the state decision variable x1, j star is 1, so we are looking at this column, right? And accordingly we have to put over here a 1 minus 2 square of x, right? This is 1 and this is 2. This is 2 and this is 1 and this is j star being 1, right? Okay, clear in the blackboard. So over here is more easy because our hypothesis started assuming that S1 has a value of 0. So S1 being 0 and x being 0, x being 1 and x being 2. So we want to minimize this value of f1, that is to say 0 plus f2 of s2 being 0, a minus 2 plus square root of 1 times 2 plus f2 of s2 being 2, the minimum, and the minimum. Now we have to take the square root of 2 and multiply it by minus 2. This is giving us a floating point. This is giving us minus 2.82, rounding a little bit, 8, plus f2 of s2 being 2 again. So the results are 0, minus 9, minus 2, minus 6, and minus 2.828 plus minus 6. And you will see that the minimum lies for x1 being 0 and the f is minus 9. F star is minus 9. So what we can do now is backtracking, because now we have to do it in reverse using the Bellman formula. In the first stage, we have seen that the optimum variable was S1 star with a value of 0, because there were no other possibility, and the minimum and the value for x1 minimum, x1 star, being 0. So the first stage is easy to solve. The second, we have to use this recursive formula. We have to, S2 star will be S1 star that has a value of 0, plus the objective function in the second stage, in the first stage, sorry, evaluated at x1 star being 0. So we have to backtracking the results. As this value was 0, 0 plus 0 is 0, it means that S2 star is 0. So now looking in the second stage for the value of x2 with an S2 star of 0, the value, if you remember, looking at the tables, was 2. So we have solved the second value of the function. Now S3 star will be S2 star plus j being 2 and x star being 2. X star being 2, I said, right? So this is giving us a value of S2 star was 0 and g of x star being 2, looking at the constraint, is giving us 2. So 0 plus 2, it means that S3 star has a value, optimal value of 2. And now backtracking in the third stage for S star 3 being 2, backtracking, looking at the tables, we will see that the optimal value was 1. And now the last, S4 star is going to be S3 star plus G3, G of J being 3 of X star 3 being 1. If you evaluate G of here, this being 1, we give 1 to cube is cube, so 1 to the power of 3 is 1. S3 star was 2, so we get an optimal value of S4 star of 3. And now backtracking for the optimal value of the state decision S4 being 3, backtracking, we get that X4 star has to be 2. So we have solved the problem, my friends. We have solved the problem. The optimal solution of this knapsack, the optimal solution is X1 being 0, X2, just collecting the results, X2 being 2, X3 star being 1, and X4 star being 2. In this way we minimize the objective function, the cost function. And with this I finish. I hope you have enjoyed, and we'll keep going. Many thanks. Bye bye.